hear me? The background is this: we had a program session, training session for the rural librarians. For that particular program, we actually started, and it so happened that we continued with this because of the results, whatever we had obtained from this drama. So, theatre always promotes us to give. Can you hear me? Promotes us to give power to truth, to take risk, and to advocate. Here. So theatre promotes us to give. Can I use this? Promotes us to give power to truth, to take risks, and to advocate for new and diverse voices. So, what was the objective? Definitely, just like all the communicators, what they have done to popularize basic astronomical concepts among the rural folks, to enhance scientific awareness and dispel common myths related to astronomy, to empower them as local science communicators in rural communities. They are not supposed to stop this, saying that we have add all these things. We have to catch up the emotions and reach them with the ideas so that they can take it further to the new generation. So when we started, see, it's very easy to tell that we'll do a drama in a college or some other places, or in the villages or the schools. But in a research center, to open up with this idea, it's very difficult. How will people accept this concept? So once we actually approach Shailaja madam saying that we want to take up this through drama and acting part. Initially everybody hesitated, but even Neeraj sir thought, what we are going to do with drama and other things, but he gave definitely a supporting hand for us to take up this concept further. And actually we should say that science communicators are also researchers, because they'll always have innovative ideas every time they bring up with the concept. So no doubt social media is available nowadays. It definitely becomes just one way of communication, but through plays which captures emotions. Just like yesterday what we saw, Galileo was here and everybody was along with Samir as though the real Galileo was here. That was the impact what we have when you take theatre to explain the scientific concepts. So when we brought this theatre concept, we had a long discussion like what are the concepts that can be brought. See, here in the auditorium, it was easily accessible. You could have one telescope, mirrors, everything. You can take everything easily. And here the people are, like everybody knows astronomy very well. So the mode of communication is also easy. Whereas, where the challenges for us was totally different. And through the play, we also brought certain activities which involved the audience also throughout the play. And we wanted to bring back some relevant and well-known serial and cinema dialogues that they are familiar with. So that to connect them with the science concepts. So this is the audience what we had. It was a mixed age group, the limited proficiency in English language, but they were very comfortable with the local vernacular language. Yesterday we had a interesting session discussing about the local language impact and the vernacular language impact and all those things. So and the time span what we had also was very limited. And the play had to reach them in this limited time effectively so that they'll carry it out in their regions, wherever they go. So appropriate regional dialects also had to be brought in this entire drama so that the understanding of astronomical concepts. In the morning session also we had some people like, even though there was discussion and other things, it's very difficult to bring back the exact concept. So it was a challenge for us through drama, to the theatre, or to the art, how to bring back those concepts also. The activities, whatever we had to design them to motivate and inspire them so that they'll continue their learning and actively engage in similar such outreach activities in the future. So we also illustrated some key astronomical phenomena as the summer and winter solstice, seasonal we brought them, each one of them in a small skit, like sub-units, like each one sub-unit will have one concept, so that they can carry out these type of dramas in their rural areas also. And the concepts were presented through dialogues and visual movements also, enabling intuitive understanding without reliance on technical aspects of all those things. Now here I am showing you the performance, how they were the performance was delivered in regional language, and it enriched definitely the local dialects, and cultural expressions also was brought in through this particular theatre activity. And the approach, it helped in bridging the gap between the abstract scientific knowledge and everyday experiences what they see. What happened was, before we started this theatre incident, nobody were ready to even to open up or to speak up with. Once we started enacting these things, they also started realizing, okay, we can approach, even though they are not scientists or some other people, we can ask them questions. They opened up their minds and they started speaking up with us also. This is one incident, like we holded the play cards of different 12 constellations, and we started asking them to move around to understand the entire concept there. Here we were bringing out the solar calendar concept part to explain all these things. And once they started moving around, they understood themselves like how it happens, how the sun starts moving, all those things. So the play was, of course, received very well. We had overwhelming positive response from participants. After the play, they took the script from us and they organized their own plays in schools and sent us the photographs also. The initiative sparked curiosity to learn more about astronomy. They started asking every day through the WhatsApp community what we had. They started asking questions, what is this, what is this. So they started making their own drama and scripts part with the help of scripts whatever we had provided. So outreach program, no doubt, what we have been seeing from past 3 days, particularly helps a lot, no doubt. But if you take theatre along with this, it goes far better, faster also to reach to the audience. So when combined with especially local language, so whichever region you are there, you take that particular region, that local dialect language to reach them, it is more easier and effortless. I don't say effortless because you need to, the person who enacts those things, it's their person's responsibility to bring out those concepts clearly so that it reaches the audience. So it also encourages community participation and long-term engagement with science. It's not like that one day we do the drama, everybody will watch us and say, put some, very good, and they go off. It should continue as a series, so that every month, one weekend, one weekday, some other day, they join together and play such activities every day in that particular place. So it was that. And yesterday you've already seen our writer Pawan Vidram Purohit, who wrote the entire script for us. I was just doing the acting part of it. So how they took the script, they took it to the local villages and they enacted this entire play. There was a small verse which played the entire song. Children started enacting that entire scene and they were showing that entire concept to the villagers around them. So this is one sec. So if time is permitting, I have. There is one more, the same concept we took back to our place also, where we could remove all the myths whatever we have through astronomy. Like some people, they don't say we won't watch Saturn at all. शनि तो हमेशा कुछ ना कुछ गलत कर देगा तो हम उसको देखेंगे भी नहीं. We had certain myths in some generation of people. So to remove these things, we used this one of the drama which we had enacted. If I have time, definitely I'll play that, and of course it is in Kannada language.
School is ನೋಡಿದ್ರೆ ಬರೋದೇ ಇಲ್ಲ. Exam ಆಗ್ಬಿಡ್ತಾರೆ. ಅಯ್ಯೋ ಸ್ಕೂಲ್ ಹೋಗಿಲ್ಲ. ಹೋಗೇ ಇಲ್ಲ. ಮೇಡಮ್ ಅವರೇ, ನಾನು ನನ್ನ ಮಗನ ಬಗ್ಗೆ ಯೋಚನೆ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಈಗ ಬರುತ್ತಲ್ಲ, ಮುಂದೆ ಬರುತ್ತಲ್ಲ, ಜ್ಯೇಷ್ಠ ಕಳೆದು ಆಷಾಢ ದಾಟಿ ಶ್ರಾವಣ ಬಂದ್ರೆ ನನ್ನ ಮಗ ಟಾಪ್ ಬರ್ತಾನೆ.
She's telling that her son will come to the top is based on the astrologers' predictions and other things, not writing up the examinations and other things. So we are bringing that fun concept here to say that doesn't happen, you have to take up the examination.
ಯಾವುದೋ ಒಂದು ಗ್ರಹ ವಕ್ರ ಆಗಿರ್ಬೇಕು. ಮೊನ್ನೆ ಬೇರೆ ನಿಮ್ಮ ಭೂಪಂದಿನಲ್ಲಿ ಶನಿ ಗ್ರಹ ತೋರಿಸಿದ್ರಂತೆ. ಈಗ ಶನಿ ಗ್ರಹ ಬಂದು ಒಕ್ಕಳಿಸ್ಕೊಂಡಿರ್ಬೇಕು.
ಅಲ್ಲ ಟೀಚರ್ ಅಮ್ಮ,
ಆ ಶನಿಗ್ರಹ ಬದಲು ಗುರುಗ್ರಹ ಆದ್ರೂ ತೋರ್ಸಕ್ಕಿಲ್ಲ ನೀವು? ಅಯ್ಯೋ ಅಮ್ಮ, ಅದು ಭೂತ್ ಕನ್ನಡಿ ಅಲ್ಲ, ಟೆಲಿಸ್ಕೋಪ್, ದೂರದರ್ಶಕ ಅಂತಾರೆ. ಅಂದ್ರೆ ದೂರದಲ್ಲಿರೋದನ್ನ ದರ್ಶಿಸ್ಲಿಕ್ಕಿರೋದು. ಈ ಆಕಾಶದಲ್ಲಿ ನಕ್ಷತ್ರಗಳು, ಚಂದ್ರ, ಸೂರ್ಯ ಎಲ್ಲ ಇದ್ದಾನಲ್ಲ, ಅದನ್ನೆಲ್ಲ ನೋಡೋದಕ್ಕೂ ಉಪಯೋಗಿಸ್ತಾರೆ. ಒಂದ್ ಕೆಲಸ ಮಾಡಿ. ಎಲ್ಲಿ ಟೀಚರಮ್ಮ? ಶನಿಗ್ರಹ. ಅಯ್ಯೋ
It's a situation where it says that you're not supposed to watch Saturn, and she's hesitant to even to watch it, and she is worried about that if she, because she has watched the Saturn planet, something else will is going to happen. So we have brought that entire concept in the form of drama, so that entire thing should be removed out. So the teacher there, she gives the 11 explanations what it has to happen, how it should not be done. It can be seen through telescopes. That incidence is what we have.
ಇವಾಗ ಶನಿ ನೋಡಿದ್ಯಲ್ಲ, ಒಂದ್ ಅರ್ಧ ಮುಕ್ಕಾಲ್ ತಾಸಲ್ಲಿ ಅದೇ ಜಾಗಕ್ಕೆ ನಮ್ ಗುರುಗ್ರಹನೂ ಬರ್ತಾನೆ. ಒಂದ್ ಬಾರಿ ಗುರುಗ್ರಹ ನೋಡ್ಬಿಟ್ಟು ನಿಮ್ಮ ಯಜಮಾನ್ರಿಗೆ ಊಟ ಹಾಕುವಂತೆ. ಅಷ್ಟು ಗುರುಗ್ರಹ ಬಂದ್ಬಿಡ್ತಾನ? ಬಟ್ ತಡಿ, ಇವಾಗ್ಲೇ ಬರಲ್ಲ, 1-2 ಗಂಟೆ ಬೇಕು.
So like this, if you take up the theatre form also, you can reach the general audience more faster. Thank you.
Thank you very much, Shubha. We have time for 1 or 2 questions. Questions, please. Yeah, here one here.
Hello ma'am, this is a very good initiative. I just have one suggestion. Can we collaborate with the theatre groups in different colleges and NSS people who do street plays so we can reach more wider audience?
Definitely, we'll be happy to share our writings in whichever language you want. This entire script, whatever we had, was in only in Kannada. If we can have collaborations, we can definitely have the same writings in Marathi, Hindi, Tamil, Telugu and other things. So we'll be able to reach larger audience. We'll be very happy, definitely. You can speak to our head of the institution here, Dr. Neeraj. We definitely will be in contact.
Sure, thanks so much.
Thank you.
Any more questions?
Thank you.
So let's thank the speaker. Thanks, Shubha. And we move on to the next talk. Our next talk is by Mukul Maske, and he'll be talking to us about exploring mood phases through role play, insights from Vigyan Pratibha classrooms.
Strong request, suggestion.
You'll have to change the setting of display.
They're getting very bad photographs
You have to do
showing
it,
this speaker only speaking to chairs. Really, we don't want our image to be like that of the conference. Let's please move forward.
today I will be talking about how classrooms can be used as effective spaces
to communicate astronomy, and not just astronomy but science in general. And as we know that the classrooms are the largest spaces where science can be communicated to students, and also and it can be done via teachers who are authentic sources of information which goes to the students. And to do this in, say, astronomy especially, we require especially three things. We need special reasoning in students, we need interpretation of data and observations, and we need guided discussions in the classroom between the students and also students and the teachers. I'm from a program called Vigyan Pratibha, and in Vigyan Pratibha, so our mandate is teacher professional development, and we make learning resources for students at grade 8th and 9th. And this is in science and mathematics both, and we also have some astronomy modules. And we focus on conceptual understanding through inquiry and evidence-based reasoning. We do hands-on activities, and we use data and representations. And we are across different states. Like we have Vigyan Pratibha goes to like around 25 states, and we conduct workshops, and we have done this for around 2,000 teachers, and we have gone to nearly 300 schools. And these workshops are not just one-time workshops, but we conduct them several times with the same teachers. So today I will be talking about a specific topic on moon phases. And why moon phases? Because moon phases are moon is the most fun. I mean, an object in the sky which everybody sees. Students observe it almost daily. But there are many misconceptions around phases of moon. And the major misconception is that the phases are caused by Earth's shadow falling on the moon. And this is not just that I'm just telling you by like talking to a few students. There have been studies both internationally and here in India which talk about these misconceptions. So there are some other misconceptions as well, that the changing of the sun moon distance also causes phase, or where you are on Earth you will see different phases on moon. Also, students find it difficult to say if you tell them how to identify the correct shape of the moon phase, especially the gibbous phase. As you might have seen in yesterday's flash talk by Movia, there is this question she had asked in a survey that about which of these phases is the right phase of the moon. Many of the students got it incorrect, and this misconception is not just for students but adults also have it. Textbooks diagrams are a helpful starting points, but additional support is needed. So what we have done is, through enactment and experience, we have designed a learning unit where students do some enactment, and they learn through this enactment about the phases. The learning progression is followed. They go through these embodied modeling in the classroom. They go through data-based, so they have some data which they have to interpret, and then the concepts are built around these two things. And so I will go through the actual role play here, and the students. So there are like three characters here. One is the sun, earth, and the other one is moon. And the students would then predict two things mainly: that which part of the moon is illuminated, and what an observer on earth would see or not see of the moon. So the focus is on relative positions and illumination. So enactment, you have sun, the moon and the earth. The moon is going around earth and the sun is stationary. We usually ask the students or the teachers that the sun is a little bit farther between moon and earth, just for an approximation, and also the height is different so that they are not in the same line. And then the students would, the student enacting the moon would go around earth, especially in these three positions. You start with this, next is this, again, and you come back. So now that here the role of the teacher is important for discussion here, and to for the students to realize that what they are seeing, an observer sitting on the nose here, suppose there is a student and you ask the students that there is an observer on the nose, the observer would see this part of the moon. This part is not visible, but this part is illuminated and this part is not illuminated. So although moon is there in the line of sight, you don't see the moon. So this is the new moon phase. Similarly, when the moon comes here in its orbit, then this part is illuminated by sun, this part is not illuminated, and from earth you don't see the back of the moon here, so you just see a half of the disk here. So this is the half moon, and so on and so forth for full moon and the other half, and then coming back to the new moon. So what it facilitates is that half of the moon is always illuminated by the sun, and the phases depend on geometry and not shadows. So here it is very evident that the phases depend on geometry and not shadows. And another important point is that everyone sees the same phase of the moon, irrespective of where they are standing. So because the earth is rotating, we also make the students rotate and accordingly, and then they realize that the earth is, everyone on earth sees the same phase. And if there is any misconception, it arrives naturally and it is addressed through discussions. And again, you go back to role play and you can take care of that. The second activity is on data. So we who have moon images, we give them moon images, rise and set times, and then they have to and also they have to note the changing shapes and boundaries of the illuminated and the dark part, and they have to then see what the pattern emerges across consecutive days here. And there are follow-up questions which enhance understanding here. And what they realize is that full moon, these are some of the key findings, that full moon rises at sunset always, new moon rises with the sun, moon rises 50 minutes early every day, and moon is also visible during the day sky. So all these are some of the misconceptions or some additional things which students learn during these activities. So here, the students then use data and observations to give meaning to some of these complicated ideas. Here, the role of teacher is very important, because the teachers encourage students in reasoning, discussions, and also the terminologies are introduced not at the beginning but after some of these enactments and discussions and observations of data and interpretations of data. And of course, the emphasis is not on this correctness alone in the beginning, but on explanations, how the students give explanations to these, what they see in the classroom. So what are the insights? We have conducted this learning unit with teachers in workshops and in many schools. The teachers themselves have conducted these units in their schools, and through their feedback and through these teacher interviews, we have found that there is a lot of engagement, high student engagement. There is a lot of peer discussion happening in the classrooms, and there's use of like spatial and causal language in students, and a deeper connect is there to the concepts. So these are the takeaways. The effective astronomy communication emerges through reasoning and not just wonder, which is sometimes is criticized for astronomy, that you only look at pictures and videos. But here the students are actually become the objects themselves and are able to then relate to these concepts. And they are able to confront any misconceptions or alternate conceptions. As you may realize that saying that the shadow of Earth falling on the moon is not incorrect in a physical sense, but they are applying it to a wrong phenomena. So here they integrate models, data and observations and dialogues to build a concept. A conceptual building is done, and teacher guidance is really crucial here. And of course the classroom based approaches are really scalable and sustainable in long term. Yeah, thank you.
Thanks, Mukul. So, questions? We have time for, yeah.
Oh, wonderful talk, Mukul. But do you really think, if suppose I am a teacher teaching in the class, it will be possible for me to complete the course of the year by this particular method?
So this is a complementary thing to what you are teaching in the classroom. So for example, there is already a phase, you teach phases of moon in the classroom, and if you do this activity, say a part of this activity along with what you are teaching in the classroom, it will just help in learning. And you don't have to do this, like, for once, I mean, in Vigyan Pratibha, it's not compulsory for students or the teachers to do it. This is to be done in, say, science circles or math circles. So these activities can be done there. So, I mean, a short answer would be to do this with as a complementary activity with your regular classroom teaching.
Yeah. One additional point I just wanted to add is that.
I just wanted to point out that this is activity has been taken by TVV and Arvind Gupta's book on learning and through. So
That's okay. Yeah. So the thing is that the additional point that I also want to point out and highlight is that, see, all our astronomical explanation are as if that we are God sitting in space and watching the celestial object. But then the way we actually experience is standing on the earth.
Right.
So this actually gives you that two positions.
Yes.
That is, when you are watching that activity, you are as if that you are in space and then seeing the celestial movement.
Yeah.
But when you are in your mind placing yourself in the position of earth, you get a earth view. So that translation of framework is also possible in this. So some of these areas which require that kind of activity, perhaps this is very interesting. Just wanted to add.
Yeah. Thank you.
There's one more question from behind. Yeah.
Hi, sir. This is a very good activity because I am myself an astronomy educator, so I also take these activities. The problem that I faced is if the audience is very larger, because only 3 students are performing in the front, so audience might get lost if the number is very large. So this is just my suggestion. What I do is I give them the Oreos before the session. So after the activity has happened, so I can check if they have understood the concept or not. So I take different groups and tell them, if you have understood the concept, show me the different phases. I tell them the name of the phases and then just show on the Oreo biscuit. Or at least.
Yeah. Okay.
I remember even years ago, we did a similar activity with Ratnashri in Hyderabad, and she did it with would eat up the part of the cream that corresponded to the face of the moon. And kids were super thrilled about that because they were obviously more enthused about the Oreos than the moon.
Yeah, and you have to realize, I mean, check if they are eating the right part.
But that's why they love it. They love it.
Yeah, so I just wanted to ask, so this is a role play for the moon phases, and then in the NCRT book and in other spaces, there is this with the light.
With the light, yes.
With the light.
Yeah.
So have you done any comparison of which one yields better methods?
Uh,
Because I feel like the play of how light falls on a spherical body is a pretty difficult concept if you are not seeing it yourself.
Right. Yeah, so I agree that there would be some limitations, but this is one of the ways you can easily do it in the classroom without any special equipments and special arrangements. So many of the classrooms don't have that liberty to make the whole space dark or everybody looking at the object together if you have a larger classroom. And so in terms of scalability, this is a little easier to understand, and this requires, so this is again an approximation, and this requires some imagination on the part of students, and here that's why different skills of students are also being engaged. And also the role of, again I've been pointing out again and again that role of the teacher here is also very important. So how she will or he will engage the students in these activities and how the students should perform.
Just a very quick comment, because we are in Bangalore, instead of Oreos, we also use idlis, and that was really nice.
So thanks, Mukul.
Yeah,
I'm sorry to move on to the next talk. Thank
We'll
you.
be happy to take questions maybe after.
Excuse me, I'm Usha, and I want to share something the same style. I use students to make them understand the external unbalanced force and the balanced force. I take three kids as you did, and one will stand in the middle, and one will pull her from the left side, and she goes to the left side, and one will pull her from the right, and she will come to the right side. So these are unbalanced. So if both the students pull her from both the ends, where should she go? She goes nowhere, she stays there. So this is how I explain them the meaning of the external unbalance and the balance force when I teach students first. This is what I want to share. That's all.
Yeah, thank you, Usha. Yeah. So we welcome our next speaker, Nilesh Chandrasekhar, and he's going to talk to us about JMRT Online National Science Project Competition and Exhibition. This that.
आवाज आ रही है आप सबको?
Yes, yes.
नमस्ते, मैं नीलेश छड़वेलकर इंडियन इंस्टीट्यूट ऑफ नॉलेज से आज आपके सामने प्रेजेंट हुआ हूँ। ये आज मैं आपको JMRT ऑनलाइन साइंस एक्सपेरिमेंट कंपटीशन एंड एग्जीबिशन के बारे में बोलने वाला हूँ। ये जॉइंट प्रोजेक्ट है NCRA, TIFR और ग्रोइंग डॉट्स इंडियन इंस्टीट्यूट ऑफ नॉलेज का ये जॉइंट प्रोजेक्ट है, और हम लोग ये पिछले 5 साल से इसको ऑर्गेनाइज कर रहे हैं। आगे नहीं जाना है। अच्छा, हम लोग सभी जानते हैं कि JMRT खड़गपुर यहाँ पे पिछले 25 ईयर्स से वहाँ पे एक फिजिकल, इंडिया का बहुत बड़ा फिजिकल साइंस एग्जीबिशन वहाँ पे ऑर्गेनाइज किया जाता है, और इसमें करीबन 20,000 से ज़्यादा स्टूडेंट्स वहाँ पे हर साल पार्टिसिपेट करते हैं। लेकिन जब कोविड का पैंडेमिक चल रहा था तो 2020 में ये फिजिकल एक्टिविटी सब बंद हो गई थी, और तभी पे अपना स्टॉल लगाते, एज ए इंस्टीट्यूट वहाँ पे एजुकेशन जो सर्विसेज हम प्रोवाइड करते उसके बारे में वहाँ पे रखते थे। लेकिन जब 2020 का समय आया तो तब पता चला कि अरे ये फिजिकल में होगा नहीं है, तो फिर ये जो लेगेसी जो 20 साल से चली आ रही है वो कहीं ना कहीं पे स्टॉप हो जाएगी। तो ये सोच के हम लोगों ने एज अ IIK हम लोगों ने एक ऑनलाइन साइंस एग्जीबिशन का कंसेप्चुअलाइजेशन किया और उसको NCRA के सामने रखा। और मुझे बड़ी खुशी हो रही है कि NCRA ने इसको बड़े पॉजिटिव वे से उसको एक्सेप्ट किया और एज अ पायलट तरीके से हम लोगों ने 2020 में इसको हम लोगों ने स्टार्ट किया था। और 5 साल के बाद जैसे फिजिकल JMRT का फिजिकल साइंस एग्जीबिशन एक लार्जेस्ट एग्जीबिशन है इन इंडिया, इन रूरल इंडिया, वैसे ही आज JMRT का ये जो हम लोग ऑनलाइन साइंस एग्जीबिशन ऑर्गेनाइज करते हैं वो भी एक देश का एक सबसे बड़ा ऑर्गेनाइजेशन ऑनलाइन प्लेटफॉर्म अभी बन गया है पिछले 5 सालों में। अभी ये किस तरीके से ऑर्गेनाइज किया जाता है, तो इसका जो पूरा प्रोसेस है वो टोटली ऑनलाइन हम लोगों ने डिजाइन किया है। हर साल इसमें नवंबर में इसका अनाउंसमेंट होता है, फिर हम लोग स्कूल और कॉलेजेस को अप्रोचेस करते हैं। उसमें 6 ग्रुप्स होते हैं जिसमें 5th स्टैंडर्ड से लेके जो 5th स्टैंडर्ड 6th स्टैंडर्ड और 7th स्टैंडर्ड का फर्स्ट है, फिर 9वीं 10वीं 11वीं का है, और फिर उसके बाद ITI उनका ग्रुप है, फिर उसके बाद जो ग्रेजुएट स्टूडेंट्स होते हैं उनका ग्रुप है, फिर उसके बाद जो पोस्ट ग्रेजुएट है और टीचर्स और जो स्टाफ लेबोरेटरी के जो स्टाफ मेंबर्स होते हैं उनके लिए एक अलग से हम लोगों ने ग्रुप डिफाइन किया है जो साइंस के बारे में, साइंस किस तरीके से स्टूडेंट को पढ़ाया जा सकता है उसके ऊपर वो अपने प्रोजेक्ट्स वहाँ पे डालते हैं। इसका जो प्रोजेक्ट का जो सबमिशन है उसके बारे में अगर हम लोग बात करते हैं तो ये स्ट्रिक्टली वर्किंग मॉडल बेस्ड कंपटीशन होता है। यहाँ पे कुछ प्रेजेंटेशन कर दिया, पोस्टर कर दिया, ऐसे नहीं चलता है। कोई भी प्रॉब्लम सॉल्यूशन या फिर साइंटिफिक जो प्रिंसिपल होते साइंस के उसको मॉडल के थ्रू स्टूडेंट को वहाँ पे प्रेजेंट करना होता है। उसके बारे में फिर प्रोजेक्ट का पूरा इंफॉर्मेशन, क्या क्या मटेरियल उसमें यूज किया गया है उसका और बेनिफिट्स किस तरीके से होगा उसको वहाँ पे डालना होता है। फिर उसके बाद 5 मिनट का वीडियो प्रेजेंटेशन बना के, वीडियो पिच बना के स्टूडेंट को सिस्टम पे मोबाइल ऐप और वेबसाइट पे अपलोड करना होता है। उसके बाद हम लोग नेशनल साइंस डे से पहले 2 दिन पहले उसका इनॉग्रेशन करते हैं और ये पूरा का पूरा एग्जीबिशन पूरे भारत और पूरे वर्ल्ड के लिए ओपन हो जाता है। और उसमें 2 तरीके से इवैल्यूएशन का काम चलता है। एक पहला जो होता है वो एक्सपर्ट इवैल्यूएशन होता है जिसमें JMRT के साइंटिस्ट और हमारा 50 टीचर्स का जो साइंस टीचर्स है उनका एक टीम है, उसके माध्यम से हर एक प्रोजेक्ट को इवैल्यूएट किया जाता है। हर एक प्रोजेक्ट 3 टीचर्स के माध्यम से या 3 लोगों के माध्यम से उसको इवैल्यूएट किया जाता है। और दूसरा एक होता है पब्लिक इवैल्यूएशन। इसमें क्या होता है कि जो स्टूडेंट या जो टीचर ये प्रोजेक्ट देख रहा है उसको कुछ क्वेश्चंस पूछे जाते हैं कि ये प्रेजेंटेशन आपको कैसे लगा, फिर ये आपको कितना यूजफुल लगा, इस तरीके से उसको कुछ क्वेश्चन पूछे जाते हैं और उसको फिर वहाँ पे रेटिंग करना होता है। इस तरीके से ये 2 तरीके से हम लोग इसको इवैल्यूएट करते हैं। फिर उसके बाद हर एक स्टूडेंट को और टीचर जो गाइडिंग टीचर होता है स्टूडेंट का उसको सर्टिफिकेशन हम लोग प्रोवाइड करते हैं JMRT के माध्यम से। और फिर हर एक ग्रुप में अवार्ड्स वगैरह होते हैं और 2 स्पेशल अवार्ड्स होते हैं जिसमें पब्लिक चॉइस प्रोजेक्ट कौन सा है कि जिसको ज़्यादा से ज़्यादा लोगों ने पसंद किया है, जिसको ज़्यादा से ज़्यादा रेटिंग दिया है उसको हम लोग अवार्ड करते हैं। और फिर मोस्ट व्यूड प्रोजेक्ट की जो प्रोजेक्ट सबसे ज़्यादा देखा गया है इस पूरे एग्जीबिशन में उसको भी हम लोग वहाँ पे अवार्ड करते हैं। फिर अगर ये 5 सालों का हम लोग इसको क्यूमुलेटिव तरीके से आउटरीच का देखें, अगर साइंस का जो ये जो आउटरीच है तो उसको अगर हम देखें तो ये 5 सालों में 4 लाख से ज़्यादा स्टूडेंट्स ने 4 लाख से ज़्यादा इसको व्यूज मिल चुके हैं। फिर जो पब्लिक इवैल्यूएशन का जो मैंने आपको बोला कि जो एंगेजमेंट पार्ट है बहुत इंपॉर्टेंट पार्ट है इस एग्जीबिशन का, उसमें 53 प्रोजेक्ट्स को स्टूडेंट्स ने खुद से उसको इवैल्यूएट किया है और उसमें अपना रेटिंग दिया हुआ है। यहाँ ये पिछले साल से अब तक क्यूमुलेटिव 1100 से ज़्यादा स्कूल और कॉलेजेस ने इसमें पार्टिसिपेट किया है। आज तक 3000 यानी 3700 के करीब प्रोजेक्ट्स इसमें सबमिट हो चुके हैं और उसमें लगभग 6000 से ज़्यादा स्टूडेंट्स ने इसमें पार्टिसिपेट पार्टिसिपेट रूरल इंडिया हो या फिर अर्बन एरिया हो, कहीं से भी इसमें वो पार्टिसिपेट कर सकता है और वो देख भी सकता है। उसके बाद ये जो हम लोग जब साइंस की बात करते हैं तो इट्स नॉट अ थ्योरेटिकल, इट्स अ टोटल एक्टिविटी बेस्ड लर्निंग की बात करते हैं। तो ये पूरा प्लेटफॉर्म उसी को सपोर्ट करता है, क्योंकि स्टूडेंट को यहाँ पे प्रोजेक्ट सबमिट करना बहुत जरूरी है और वो मॉडल होना जरूरी है, और उसमें कुछ उसको खुद को वो करना है, उसको एक्सप्लेन करना है, तो उसके जो एक्सप्लेनेशन स्किल्स है, प्रेजेंटेशन जो स्किल्स है, वो भी इम्प्रूव करने में ये एक अच्छा एक प्लेटफॉर्म अभी तक का साबित हुआ है। फिर उसके बाद इसका जो एक फीचर है वो हम लोगों को थोड़ा सा एंगेजिंग के लिए बहुत अच्छा लगता है कि स्टूडेंट खुद यानी एक्सपर्ट्स उसको इवेल्युएट करते, दिस इज वन पॉइंट, लेकिन स्टूडेंट टीचर्स भी एज अ पब्लिक उसको इवेल्युएट करते हैं और उसको एंगेज करने में ये काफी हद तक ये प्लेटफॉर्म अभी सक्सेस हुआ है। उसके बाद जो ट्रैवल का जो कॉस्ट होता है या फिर जो ट्रैवल और उसके में जो कॉस्ट है वो भी इसमें ये ऑनलाइन प्लेटफॉर्म से पूरा एलिमिनेट हो गया है। फिर उसके बाद अभी आप मैंने जैसे बोला कि फिफ्थ स्टैंडर्ड से लेके ग्रेजुएट पोस्ट ग्रेजुएट तक के सभी स्टूडेंट्स इसमें पार्टिसिपेट करते हैं, जो फिर एक ही प्लेटफॉर्म पे सभी जो एज ग्रुप है उनको हम लोगों ने यहाँ पे इनकॉर्पोरेट किया है। और दूसरा कि जैसे अभी बहुत सारी चीजें हम लोग बात करते हैं कि रूरल इंडिया में साइंस किस तरीके से पहुंच रहा है, लेकिन जो डिजिटलाइजेशन के जो बेनिफिट्स है, तो इससे भी ये रूरल इंडिया हो या फिर अर्बन इंडिया हो, दोनों को एक प्लेटफॉर्म पे लाके एक कॉम्पिटिटिव स्पेस क्रिएट करने में ये प्लेटफॉर्म काफी हद तक साबित हुआ है। अभी 5 साल तो हम लोगों ने इसमें काम कर लिया है। जब हम इसको और आगे देखते हैं इस पूरे प्लेटफॉर्म को, तो हम लोगों को पहला चीज ये लगता है कि हम लोग इसमें पिछले साल हम लोग इसको भारत की बाउंड्रीज पार करके इंटरनेशनल लेवल पे भी हम लोगों को पार्टिसिपेशन इसमें मिला है। तो ये कोलैबोरेशन जो है नेशनल और इंटरनेशनल लेवल का, इसको हम लोग और डीप करना चाहते हैं और इसको और स्केल करना चाहते हैं। दूसरा इसमें ना बहुत अच्छे कंसेप्ट स्टूडेंट्स डालते हैं कि कुछ भी जो प्रॉब्लम सॉल्विंग कंसेप्ट्स होते हैं या फिर जो अच्छे कंसेप्ट होते हैं, जो मॉडल होते हैं, तो उसको हम लोग क्या जो स्टार्टअप इंडिया का जो प्रोग्राम चलता है या फिर इनोवेशन का जो प्रोग्राम चलता है, उसमें लिंकअप करके उनको एंटरप्रेन्योरशिप के माध्यम से उसका कुछ प्रोडक्ट या फिर कुछ इंडस्ट्री उसको कर सकते क्या है, इस तरीके से जो अच्छे प्रोजेक्ट्स है उनको वहाँ पे उस दिशा में भी लिंकेज क्रिएट करना आगे चल के हम लोग चाहते हैं। फिर इसमें एक और चीज है कि जो क्वालिटी ऑफ द वीडियो एंड एंगेजमेंट होता है वो काफी कभी-कभी सभी स्टूडेंट या फिर सभी टीचर्स को अच्छे तरीके से जमता है, ऐसे भी नहीं है। तो एक ट्रेनिंग मॉड्यूल हम लोग डेवलप करें कि जिसके माध्यम से कि अच्छा क्वालिटी का और अच्छे एंगेजमेंट का वीडियो बना सके, जो ज्यादा से ज्यादा जो उसके व्यूअर्स हैं उनको वो एनकरेज या फिर उसको एंगेज अट्रैक्ट कर सके। तो इस तरीके से हम लोग आगे बढ़ना चाहता है। दूसरा ये अभी जो एग्जीबिशन का जो फॉर्मेट है, इसमें ऐसा कुछ ट्रैक बेस्ड सिस्टम नहीं है कि एस्ट्रोनॉमी हो गया या फिर फिजिक्स हो गया या फिर केमिस्ट्री हो गया, ऐसा कुछ ट्रैक बेस्ड या थीम बेस्ड उसका नहीं है। वो सब सब्जेक्ट को एक ही प्लेटफॉर्म पे ला रहा है। तो आगे चल के उसमें थीम बेस्ड कुछ कंसेप्चुअलाइजेशन करके ये प्लेटफॉर्म हम लोग डेवलप कर सकते हैं क्या, उसके बारे में हम लोग आगे बढ़ना चाहते हैं। और एक चीज है इसमें कि अभी ये कंपटीशन खत्म हो जाने के बाद हमारा जो स्टूडेंट का जो कनेक्ट है वो कहीं पे रुक जाता है, तो उसको मेंटरिंग मिल सके। जो अभी साइंस फ्रेटर्निटी है, जितना भी जो मेंटर्स है उनको किस तरीके से उनको कनेक्ट करके उनका जो नॉलेज है उसको हम लोग आगे बढ़ा सके, इस बारे में हम लोग ये पूरा प्रोजेक्ट हम लोग देख रहे हैं। जैसे ये एनसीआरए और आईआईटी का एक कोलैबोरेटिव प्रोजेक्ट है। एनसीआरए के बारे में हम लोग सभी जानते हैं कि ये वर्ल्ड फेमस ऑर्गेनाइजेशन है। इंडियन इंस्टीट्यूट ऑफ नॉलेज के बारे में अगर मैं बताना चाहूँ तो हम लोग जो नेशनल एजुकेशन पॉलिसी के जो ऑब्जेक्टिव्स है उसको जो एजुकेशनल जो स्टेक होल्डर्स है जिसमें स्टूडेंट, टीचर्स, फिर स्कूल मैनेजमेंट एंड पेरेंट्स, ये जो पूरा स्टेक होल्डर्स है, तो उनके साथ में मिलके जो एनईपी के जो ऑब्जेक्टिव उनको अचीव करने के लिए आईटीसी एआई का हम लोग इस्तेमाल करके वो ऑब्जेक्टिव अचीव करने के लिए हम लोग कमिटेड बहुत सालों से काम कर रहे हैं। दूसरा, अभी जो लर्निंग बेस्ड आउटकम जो इम्पोर्टेंट पार्ट है न्यू एजुकेशन पॉलिसी में को उस तरीके से हम लोग पर्सनलाइज एजुकेशन करके वो किस तरीके से हासिल कर सके, इसके बारे में भी हम लोग एक अच्छा खासा काम कर रहे हैं आईआईके के माध्यम से। दूसरा, पिछले 20 सालों से हम लोग अलग अलग प्रोग्राम्स करे एजुकेशन में, और उसमें करीब 1200 से ज़्यादा स्कूल्स और कॉलेजेस तक हम लोग पहुंचे हैं। और अभी जो हमारा ग्रोइंग डॉट्स प्लेटफॉर्म है आईआईके का, उसको 1 लाख से ज़्यादा स्टूडेंट्स उसका लाभ ले रहे हैं। हम लोगों को नेस्कॉम फाउंडेशन, वोडाफोन फाउंडेशन और डिजिटल एम्पावरमेंट फाउंडेशन से भी अवार्ड मिल चुका है नेशनल लेवल्स के। तो ये था। और इस सिंपोजियम के माध्यम से मैं अभी आप सबको एक आह्वान करना चाहता हूँ, अपील करना चाहता हूँ कि ये जो अभी इस साल का जो 2026 का जो जीएमआरटी का जो प्रोजेक्ट है वो अभी ऑनगोइंग चल रहा है। उसका लास्ट डेट ऑफ रजिस्ट्रेशन है 20 फरवरी 2026। तो मैं आप सभी से मैं निवेदन करता हूँ कि आपका जो रीजन है या आपकी जो कम्युनिटी है उसमें इस प्रोजेक्ट के बारे में आप उनको स्टूडेंट को यहाँ पे रजिस्टर करने के लिए प्रोत्साहित करिए। मैं आपसे एक मेरा रिक्वेस्ट करता हूँ। दूसरा कि अभी डिजिटल प्लेटफॉर्म में हमारा पूरा डेवलप हो चुका है। अगर आपका कुछ भी इनिशिएटिव हो जिसको हम लोग ये वाइड रेंज ऑफ इंस्टीट्यूट्स और स्टूडेंट के पास अगर आप पहुंचाना चाहते हैं तो वी विल बी वेरी हैप्पी फॉर इट। और दूसरा एक तरीका है कि अगर हम लोग कुछ कोलैबोरेटिव तरीके से, कल परसों से हम लोग बहुत सारे आउटरीच के प्रोग्राम्स देख रहे हैं, तो इस सिंपोजियम के बाद हम लोग डेफिनेटली आप लोगों से कनेक्ट होंगे या फिर आप हमसे कनेक्ट होइए। और ये जो मिशन हम सब चला रहे हैं कि साइंस को और अच्छे तरीके से अपने सोसाइटी में हम लोग इनकलेक्ट कर पाए, तो इस मिशन में सभी मिलके हम लोग काम करेंगे। इसी नोट पे मैं यहाँ पे रुकता हूँ। थैंक यू।
बहुत ही अच्छा इनिशिएटिव है। हम लोग सिर्फ एक सवाल कर सकते हैं कि क्या, बिकॉज थोड़ा टाइम का।
हेलो सर, आपका इनिशिएटिव बहुत इंस्पायरिंग है, तो इसके लिए थैंक यू वेरी मच। मैं क्वेश्चन ये पूछना चाहती हूँ कि आपने मेंशन किया कि आप रीजनल लैंग्वेज में पार्टिसिपेंट्स अपना प्रोजेक्ट अपलोड कर सकते हैं, तो क्या आप एक सेंट्रलाइज्ड ट्रांसलेशन करते हैं ताकि पार्टिसिपेंट्स एक दूसरे के प्रोजेक्ट्स को एक्सेस कर सके?
अभी इवैल्यूएशन के लिए तो हम लोग उसी लैंग्वेज के टीचर्स लाते हैं कि उसको ये हो सके, लेकिन जो गूगल का एक ट्रांसलेशन का ऑटोमेटेड जो सिस्टम है तो उसको हम लोग अभी अपने वेबसाइट में हम लोगों ने इंटीग्रेट किया है। जो हर एक जो पेज होता है उसको स्टूडेंट को जिस लैंग्वेज में चाहिए उसको ट्रांसलेट कर देता है।
One more question, fast question. Any more questions?
Hello sir. So with regards to when students upload their videos in their regional language, so in terms of the public engagement when they are getting the view, like when you are evaluating it, how was the difference in terms of the population being engaged? It could be different for language like Hindi versus regional languages, right? How do you make sure that that is taken into account?
हाँ, करेक्ट। तो अभी दो लैंग्वेजेस का यहाँ पे ज़्यादा एंगेजमेंट है। एक तो हम लोग महाराष्ट्र से, तो मराठी जो स्टूडेंट्स है वो ज़्यादा इसमें पार्टिसिपेट करते हैं, और हिंदी बेल्ट में भी इसका अभी पॉपुलराइजेशन यानी वो बढ़ रहा है। लेकिन जो साउथ इंडियन जो लैंग्वेजेस है तो उसमें अभी भी कम है, तो उसको हम लोग ज़्यादा एक्सप्लोर करना चाहेंगे इन नेक्स्ट ईयर्स। और इंग्लिश में भी स्टूडेंट्स में ज़्यादा से ज़्यादा पार्टिसिपेट कर रहे हैं। तो 3 लैंग्वेजेस में अभी ज़्यादा है और बाकी के लैंग्वेजेस में हम लोग उसको और प्रमोट करना चाहेंगे।
Thank you very much. Thank you. We move on to our next talk. Our next talk is by Mahesh Gade. Mahesh Gandhi, sorry. He'll be talking about integrating experimental astronomy and amateur radio communication in school education, and a multidisciplinary model for public engagement and scientific development. Yeah, Mahesh.
Mahesh MB from Mysore. I represent Excel Public School. I'm a STEAM coordinator and also the custodian of Amateur Radio Club, a licensed club, and Astronomy Club. Today we are talking about integrating experiential astronomy and amateur radio communication in school education. There are two pillars which I'm happy to say that those were my hobbies, and now I am pursuing it as a profession. So we'll talk about how in Excel, as a model case in Excel Public School, Mysore, how we have integrated it as a case study here. We're going to talk about that. The first thing is astronomy and amateur radio, hands-on experiential as a SEN model. Here, as a being myself as a STEAM coordinator, it has been challenging to put this together and putting all my own experience. We started last year, I started some hands-on activities. So it particularly the concept of physics, electronics, space science, communication all together into the application. To introduce our school, and we are the registered space tutors, and we have been, and also to give a brief intro about the amateur radio, ham radio. When there is no internet or mobile communication, we do communicate. So I myself, being a license holder, general grader, had an eligibility to start our club in our school. It's very few in India, a school having a licensed amateur radio club, and we are called our call sign. There will be a call sign for that. VO2TQA is our club station, and myself, VO2YYA is my call sign. And the license is issued through Government of India, Ministry of Communication. So there will be an examination for that, and after that, a general grader can start a club. So in our school, the program structure, there are three verticals, exactly what we are implementing. First thing is a skill development program. Every student in the school should take up one of these skills. There are 12 set of skills, and one among them is amateur radio and amateur astronomy. So they are paired actually. A student will pursue from class 6 and above, they will pursue this, and for 6 months from class 6, amateur radio will be there. For 20 students, we choose 20 students, and the same students in another 6 months, they'll go to the astronomy. They are like paired skill developments, so that they are integrated. And coming next is open club model is there. So those who don't get an opportunity to come to the STP skill development program, they get a chance to be a part of the open club, including teachers, mentors who are interested, they'll join. And there are tinkering classes. Every student will come once a week, will come to our lab, and we'll start them with the basic electronics. And we have prepared our modules for that, starting from basic electronics to IoT. We cater them, and those who are interested with a particular subject, they'll move on to different projects. So we start with every year we start with an annual planner. We release a calendar, and students will make a note of it, and they will be available. So any special events, these are some posters from different events. We release a poster before an event, and it's open for students, even for parents, teachers, and public. We conduct the events, and the calendar will be published in the beginning of the year. And just to few events here, National Space Day that was celebrated in our. This was interesting event on Zero Shadow Day, International Asteroid Day that was observed in our institution, and here solid skies, we get support from different organizations like Cosmos in Mysore. They are helping us with conducting the events. And planetary parade, this was the top of the year last year, and we conducted several events on planetary parade. And this is one of the interesting thing here. This is the place where we are integrating the astronomy with amateur radio. We're going to start with the spotting of the ISS and move ahead on different experiments. So these are some participation of events conducted as part of the outreach by other institutions, Cosmos, IAA. So our students participate with the activities conducted there. There is an activity on asteroids. This is a part of the ISRO Space Day, National Space Day. The students participated in different competitions. And this is one of the interesting thing, and also I am excited for tomorrow's visit. And near in Karnataka, in Gauribinur, we have a radio observatory by Raman Research Institute and IAA. So our students had an opportunity to visit, and they got an interest of what exactly, and ignite about the radio telescoping. Just a glimpse of the activities we do. We have a club station, we have a base station in our school, and we conduct an interesting activity called a fox hunt, and we are mixed with a treasure hunt, and students have to hunt the transmitter. We conduct workshops on building a radio, FM radio. Without license, anybody can receive the signals. Students make their own audio FM radio, and they can build an antenna, connect to it, and this is a part of the Morse ham radio activity. They build their own Morse code and they build, and this is an interesting activity on SSTV reception from International Space Station. So anybody can do that, reception can be done, and these are the glimpses of different astronomy events we conduct, and the constellation box we have constructed to explain the stars. And daytime astronomy, because most of the time night sky watches when wash out, these are the interesting things. And this is a 3D printed moon. We show them to locate different parts of the moon. And we have a 14-inch celestron in our institution where regular activities are conducted. This is a glimpse of one of the activity. Okay, I'll just I run through some of the materials we have done for our activities. DIY moon. These are the handouts we made for the activities. Phases of moon, sundial, making a spectrometer, and spectroscopy. And I'm happy to say that some of the activities Toys from Thrash has helped a lot, and I've been following from childhood, and some of the experiments were done. This is a DIY speaker, a simple ball and a magnet inductor has been placed. Literally they can hear the sound. So DIY radio, and this is an interesting thing on DIY resistor and capacitor. Students make their own resistor and capacitor. So as a part of the amateur radio, they should know the basic electronics to get their license. So we do the hands-on activity and they connect them with a syllabus. A 12-year student, above 12 years, can take a license. So this is one of the interesting thing we, as part of the project we done XLFM 106.9, we have made our own radio station. So public address system becoming like connecting wired thing is monotonous and expensive. Just less than a cost of 5,000 rupees, we constructed a campus radio where students are actively, they only designed this, and at a frequency we are able to do the transmission within the campus. And this is very motivating things for the students. When ARISS, Amateur Radio in International Space Station, will transmit greeting cards in predefined schedules, and our students, they're capturing those images. A simple thing I would like to say about SSTV is the JPEG image is converted into an audio signal and then transmitted through RF, and we decode it through our amateur radio receivers, and we decode that back to the image back. So that is an activity students conduct, and then an award will be sent as we send the evidences. So outreach activities for other rural students, as we have the observatory, we do conduct this in our school. And this is an interesting thing which we started from last year for plus 2 students as a part of the syllabus. CBSE, they are supposed to do the internship. This time we did an internship on astronomy. 2 students, when the others were going towards the software companies, and they approached me, and the management given the permission. And you can see an interesting telescope here. They have undergone a different, it's a 15 days program. Each day they have recorded what have done, day astronomy, and coming to, they constructed a telescope on an optical bench. They studied how we can make a telescope, one refractor they did, and this was the final output. You can see just how the resolution is, and they did some hands-on with the 3D printing to improvise the telescope, how they can make with the assistance of an expert who knows 3D printing. So some of the achievements from our school, the youngest hams are from our school. In ham language called YL, young lady for girls and old man for boys. It's an etiquette in the ham. And coming to this, 6 students, they were, when they got licensed, fortunately they got an opportunity to go to ISRO as part of the historical event when Shubham Shukla was on board. They are part of the historical event, and that motivates the students to be a part of the activities like this. And this is one of the, we also give encouragement for the students to present their papers. This was one of the paper presentation, scientific paper presentation recently happened in ISRO, and one of our students got the first prize for presenting it in Kannada. And these are the innovative projects which got national recognitions through ham radio. To name a film, there is a anytime education. We connect the communication through audio, and there will be a pre-content where the students, where there is no communication at all. And this is healing signals, and SSTV what I showed is for hospitals. When there is no communication, medical records can be transmitted through the ham radio. And one more activity is on a rapid rescue flood detection. This is a very interesting activity. It can give a signal of around 7 to 8 kilometers when there is a flood. So yeah, coming to the replicable model for schools, we can establish amateur radio. We can establish an amateur radio club and align different activities as I explained with the STEM curriculum. And we can partner with different, as we are getting a support from ISRO, Cosmos, IAA, can partner with them and document and share the best practices. That is what, and I just acknowledge Excel Public School, my management is giving all support for conducting all the activities. ISRO, IAA, Cosmos, and ARISS, the amateur radio activities. And we have an ATL lab, adult tinkering lab in our school, which gives an opportunity for the students to explore, and we guide them. And especially I thank SEI 26 for giving this opportunity. That's all, my friends.
Very good answer. Actually, even we have done hand radios with Astro, and I think it works very well. There's a very beautiful book and movie called Contact, Carl Sagan, which actually talks about ham radios and astronomy. So questions? Yeah.
Yes, sir. Very impressive talk, because this doing it at school level, it's a tremendous job. Because even most of the colleges may not be able to achieve that. And whatever hams are there, they are mostly in IITs and engineering colleges. So congratulations to you. So my question is actually, these students, okay, passing the elementary electronics is fine, but how do you manage to teach them the Morse code, and how long do you think was taken for these school students to pass that?
Yeah, that is thing is like the Morse code is just those who are interested. For the examination part, Morse code is not required. There is a 2 grades. One is restricted grade and the general grade. We just start them. We give them a challenged to take the general grade, so that at least they pass the restricted
No,
grade.
it is not girl who got the ham certificate, so she must
Yeah.
have done the Morse code also.
No, she got the restricted grade, but the other boy, he passed the Morse code. He was with me from class 6. Now he is in class 12. And in class 9, he became the youngest ham to pass the general grade. The Morse code is, earlier it was, Morse code was compulsory. Now they have exempted. There's 2 grades, restricted and general grade. For the restricted grade, there is only theory paper you have to pass, basic electronics and rules of ham. For general grade, you need to pass the Morse code. But we start with them, they enjoy doing it. They use it for different purposes. They signal with the Morse in class.
No, it's really mind-blowing, the kind of work you have done. It's
Yes.
really-
Yes.
Any more questions? Yeah, so we are actually running 9 minutes late. So thank you very much. Thank you, sir. And we move to the last part of this session. But please don't go, because the next one is back to back immediately after this talk. Right? So the next talk we have is by Dr. Ashish Rathodi. He'll be talking to us about Stars Over Hills, empowering teachers and students for stormy outreach and rural outreach of Uttarakhand.
Hello everyone. Am I audible? Last. Okay. So I'm Ashish, and I'm a faculty member of the DRBNS. It's an autonomous college of HMB Hall Central University. And here, first of all, I would like to, thanks to organizer of this symposium that they give me the opportunity to interact with you all. And I have, here a lot of science communicator from last 2 days, and all are doing very well, wonderful job. Here, as our mandate that how the higher education system of this country connect with the school education system. So we have proposed one project that is known as Star Over the Hills. It's a kind of empowering teachers and their students through the astronomy outreach, specifically in the rural school communities of the Uttarakhand. And we will let you know more about this as we proceed in this particular presentation. First of all, I will take you at Uttarakhand. As yesterday we have received wonderful snowfall, and as far as the Uttarakhand, if you know, it's often known as the Devbhumi. It's a kind of land of gods. Not only that we have the holy temples, holy Kansas, and all these things, but we have a wonderful landscapes. We have wildlife sanctuaries, Rajajis, and all the things we have. So as far as the some data concerned with the Uttarakhand state, that we are one of the leading state in this country, that geographical area, underrepresented district, population density, and as far as the literacy concerned, that we are good enough in that way, more than 78.8%. But besides all these good things, we have a lot of challenges in rural communities. That the first thing is, as most of the states are facing these migrations from the rural to the urban areas, and we are also facing the migration, challenges in the rural community of Uttarakhand. And the agriculture as well, because most of the revenue generation from the agriculture, rural community generate their livelihood generation from the agriculture, but most of the agriculture is based on the, terrace farming is there, so agriculture depends on the monsoon. But when we receive the monsoon, the disaster happening, and so all these challenges we have facing regularly, And other thing is educational institutions in the rural community, they don't have a good enough infrastructure, as well as the medical health and health infrastructure in the rural community is very poor. But still government is doing a lot of things, but the main thing is for whom they will do, even migration is happening rapidly in the hilly communities. So in that context, the scientific temperament and the education, literacy, whatever, all these things, the outreach we are doing there is very difficult. But somewhere we are managing in that way. So as far as the astronomy is concerned and astrotourism, because Uttarakhand is a destination for tourism, so astrotourism is maybe the big concern. As I think you all know that how the hilly states, just Ladakh and all these hilly states in this country are promoting the astrotourism very well, because we are very privileged that we have a wonderful sky for sky gazing and all these things. Now in this slide you can see the observatory at Devprayag, where the Ganga forms the confluence of the Bhagirathi and the Alkananda, and oldest observatory time that was established by the Acharya Pandit Chakravarti Joshi, but he was not indulged with astronomy. He was basically a famous astrologer. And you know, sometimes we are afraid in this country that we have a regular column in the astrology in the newspaper, but we don't have a regular column in astronomy. But it's our responsibility how we can propagate the astronomy as well, that it will be the regular column. So, but anyway, he was so fond of the stargazing or whatever, that time he was brought the two telescopes from Italy at their observatory. It's known as Nakshatra Veshala. It was, I think, around pre-independent era, 1946. So it is the oldest establishment in kind of a a telescope settlement in the hilly regions. Now, other things you know very well that Aries is there. It's a modern establishment of this. And in the last couple of years, you know, the Uttarakhand government, it is it's the first kind of initiative taken by the Uttarakhand government, that it announced that Astro Village at Nainital, and a lot of tourists is going there, and I think most of the youth went there for the camping and all. I think Kartikeya was there. Yes. Yeah. So this is the basic, concept related to astronomy and astro-tourism in Uttarakhand. Yeah. But, you know, all these things which we have discussed, that is only the for astro-tourism, and people are going there, making parties, as well, and spending a wonderful time and entertainment for that one. But what's about the rural community, and especially rural school students, how they connect with the science? And so we have, before proposing that particular project, that we have a kind of assessment that it is a limited education resources in the hilly remote school communities, because lack of infrastructure. Even most of the school students, they used to learn in the open fields, and low STEM engagement, because infrastructure not quite well in some schools. Now the adult tinkering labs is going there, but we know the reality in most of the states. What is the reality of the adult tinkering lab? Nobody is catching all those things in a better way. So somewhere we have a low STEM engagement in the rural school students. Now, as the school authority of the states, in every state, they have established the DIET, District Institute of kind of a Institute of for Educational Training purposes. They have established a DIET, but they don't have frequently kind of a workshop on astronomy and science specifically. So they have a inadequate teacher training also in those district level. And other thing is that in the hilly states everywhere, I'm not talking about the Uttarakhand, but most of the hilly states, they are they have a good revenue from the tourism. So they especially the rural communities offering the homestays. So but we are also promoting that how community can be engaged with the astro, so they can convert their homestay into the astro stay as well. Already all these exercises, I think, is going on the Ladakh side. So, and but besides all these assessment, the students, when we just interact with them, they have a great enthusiasm for the learning, specifically astro related topics. Now these are the need assessment we have. Now all these things, big questions we have as an academic institution, as academic educators, we have big questions. We nowadays NEP is the buzzword in this country. So decline trends in science versus national GRI missions, and you think that I hope that you will well aware about that. Now mostly the newspaper always highlighted that college teachers raise concern over the decline in enrollment in science courses, and there is some news in the newspaper that most of the departments which concern the fundamental sciences, they have completely closed, because due to the low enrollment ratio in their particular undergraduate and postgraduate courses. So it's a big challenge for physics, chemistry, biology, and mathematics faculties also as well. And in the other sides, the NEP 2020 advocates that they have to enhance the gross enrollment ratio by 50% by 2035. So in that way, we assume that astronomy may be the gateway to enhance the gross enrollment ratio, and we can appeal the imagination of students towards, so they can pursue the physics, chemistry, mathematics, even the fundamental sciences in their undergraduate program. So this is our main concern. So we have proposed this particular, because this particular project we have proposed closed, and we are enough fortunate that we got grant from the NCST department, from the Department of Science and Technology, to to conduct to implement this particular project in the hilly communities of the school. And somewhere, when just our earlier speaker, that I appreciate that he is a STEAM coordinator. When when in the era of STEM, when you transit from the STEM to STEAM, it's a good thing. So somewhere we are influenced by the literature, and so I have quote this one. This can echo, and this particular phrase from William Black, where you can see the word in the grain of sand. Somewhere we can resonate these things with the star over the hills, where when any students from the rural communities, they see observe the sky through the telescope, definitely they feel the wonder of the cosmos in their own way. So this is the project which is supported by the DSC NCST department in 2024, and from the last year we are conducting a lot of workshops and the outreach programs under the aegis of the DSC this program. The objective of this particular program is to introduce rural government school students to fundamental concepts of astronomy and space sciences, spark curiosity and interest in scientific inquiry and discovery, and all these objects are also aligned with all the things which we have already heard here from the different science communicators. So our main motto, we have already told you that how we can enhance the enrollment ratio in fundamental sciences, specifically in the undergraduate program, through this particular project in the school level. So in this particular project, we have targeted 4 districts, and these 4 districts intensely targeted that because they share their international boundaries, and these are border districts of Uttarakhand, Tehri Garhwal, Uttarkashi, Champawat, and Pithoragarh. In this particular way, we have 3 districts. They share the international boundaries, so they are the border districts in Uttarakhand. But the first one is Tehri Garhwal, because it's my native place, so I choose this particular way that charity should begin from the home. So in that way, I have choose Tehri Garhwal first one. Okay. So in this particular project, 500 students of the secondary school in the remote place of Uttarakhand we are targeting. 200 teachers and educators will be directly benefit from gaining knowledge and skills in astronomy, space science education, which they can integrate into their teaching practices. But before implementing this particular kind of a project, then we have up to the pragmatic intervention of the impact. I think most of the science communicators who are working in this particular field, they are approaching this particular approach, pragmatic intervention for the impact, because it's a realistic, it will be the scalable. So this particular approach, when the students were part the kind of a workshop that our astronomy education, in that way they can make it hands-on way, that telescope gives hands-on telescope making or sky observation by the students. So in this particular exercise, we collect also the experts from the community as well. You can see this particular gentleman who is working with me into making that particular telescope. He is a retired colonel from the army. He is now 19 years old, but he is so enthusiastic to impart the astronomy education, specifically to making how to make their own telescopes from the West materials. So we always engage the kind of people from the community as well. We also conduct the stargazing session in different. We are not conducting these things in Dehradun, because Dehradun is a well-established city. We are taking the astronomy at their places as well. Okay, so that is our unique things, that we are not conducting all these things in particular places. We are going to their places and impart the astronomy in that way. So, but when we do something in the territory of schools or in things, we have to communicate with the school authority as first. That is, we have established a MOU with the SCRT. SCRT is generally the local NCRT chapters in the states. So we have established a MOU with them, so that it makes easy to us communicate with the school teachers as well, because most of the time that the school school authorities, they know they are not interested to take they will not entertain you in such kind of, because school teachers already have a lot of works. Government school teachers have already a lot of works. They are engaged in different, they have to conduct unit tests, whatever. Sometime, okay. So all these things we have established MOU in that way, and through this astronomical reasons, and then we have certified them as a teacher as well as students. So we conduct the workshop for different diets also, and somewhere if we are not able to reach in person, so we are connected through the online mode, and these all are the simulations through the online which we are imparting for teacher. And these are the eminent speakers, and maybe you will be in the list, and who always accept our invitation to interact with our students as well. So we have also started Punarvasu e-magazine, where the students contribute their articles, their particular observations around them, and then we can publish it bi-monthly through our college portal. So this is also this particular we can say it's my own house in the hills, and we have established the one telescope over there. So I started the things from my house, so we can convert the homestay into the astro stay as well. So we have converted at least 4 or 5 astro stays over there in the tier districts. So it's a students. We are also engaging the exchange program, that how the renowned school students connect with the rural school community. These are the students from the Doon school, very famous school in this country, and we bring them to the rural settings, and then they connect, they share experience of them. So all these are community engagements, so we also done in this way. And recently in the month of November, we have started Astro Chai and Sky. It's a monthly meet in our college, where we bring the students from neighborhood school college area. So this is our all exercises which we are doing, and I think we are running with time. So, but in the curricula, this is some study which we have done, that in the astronomy school curricula like this one, but a lot of gaps in the curricula, because if we concern with the astronomy topics, the barrier of conceptual learning in astronomy, that is not very clear. So we have to do a lot of works in that way, how we can rectify all these barriers specifically in the curricula, and especially the outreach team of IPA and the TLC center can also help us in that way. And this is the particular observations which we have done, and we have showcased this one in the Astronomy 10 at HBSC, where we study 100 students, we impart, we mentoring them, and 40 students pursue after 12th. Well, in postgraduate physics as undergraduate subject, and physics in diploma category and other fields. So it's not a great achievements, but we have made a small dent in that way, where the school students, especially rural school students, drop out after the 12th standard. So all these things we have done, and recently we have conducted a wonderful workshop with IEU, and Virendra was here. He is our chief resource person for that one. So with this note, I would like to thank all these things. And this is the another way we have, that how we can translate the wonderful article, and how we can communicate science especially in the rural schools of Uttarakhand, which know the Hindi very well. So most of the article I've translated and then circulated among the students. So with this, I think that with this help, we can we cannot impart education astronomy in the rural setting of Uttarakhand. Thank you very much.
Thank you very much, Ashish, for a lovely talk. And one question. Please stay on, because we have the next session back to back. So please stay on. You can work on it. Okay. So first of all, I'd like to thank all the speakers of this session. Thank you very much. We are about to see running out of time, but since we have only one talk in the next session, I think we could take that.
Priya, you wanted to take one question?
Yeah.
You wanted to take one question? There is a question.
One question. Okay, yes, one question.
Hello sir, Tilaka here. So as you mentioned, there is a decline in enrollment in science and maths. So what do you think, what is the main issue? What do you think is the gap over there?
Chandrayaan and Suvanshu Shukla went to the space. After that, we received a lot of students in astronomy. But when they just go in the deep of the astronomy, they just interact with the mathematics and the calculations. They just go. So that is the thing. Yeah, in the first way we can say astronomy may be the gateway, because it give a flavor of some kind of a glamour in the education. So
session, and the next session is on a different theme. The theme we now will be talking about is dark skies, using dark and quiet skies, and as well as astro-tourism, for which we have only one speaker, Anupama. So Anupama is going to be talking to us about dark skies and sustainable livelihoods, institutionalizing astro-tourism through policy and capacity building in the Andaman and Nicobar Islands.
Sure, thank you. Hi everyone. I'll make it as quick and as painless as possible. I know you're tired after listening to a lot of talks. So I'll directly jump into the topic. Myself, Anupama, and I'm representing Directorate of Tourism as Andaman Nicobar Islands and CSTEM, the knowledge partner. I'll talk about the background and the introduction maybe if time allows at the end of the session. I'll directly jump into the topic. Yeah. So most of you know about Andaman as a tourist place, and why Andaman and why astro-tourism within the Andaman. As you can see on screen, like it is one of the India's darkest and quietest night skies. I don't know how many of you have visited Andaman or had the opportunity to observe the night sky. They have really good night skies and really good nature, and low light pollution, stable weather windows. So there is an established identity of tourism within Andaman. That means there is a continuous inflow of tourists coming in throughout the seasons, including off seasons for further other activities, including ocean-related activities, hiking, bird watching, and astrophotography aspects and all. But there was a critical gap where the dark skies are largely unrecognized as a public engagement and as a livelihood asset. And so the astronomy outreach was mainly done as an episode-wise, mostly during if any external resource people are coming, or astrophotographers who already know about the locations when something like that happens. The outreach was done, and it was very episodic. So the key challenges were, as told, the dark skies were undervalued in tourism planning. There is already an established tourism regulation board and everything, but dark skies were not included in that, or astro-tourism as such was not included in that. And there was a huge dependence on external experts, so that there was a limited local capacity. The community members were not able to access or make use of the opportunities of the vast and dark night skies. There was also formal absence of formal recognition of astro guides as such. And so why this matters, why the intervention matters is dark skies are very fragile, as many of you are already involved in the dark sky preservation. So without local ownership and sustainability is very much impossible in such cases. So that's when, in its first of a kind in India, the Andaman Tourism Department, Directorate of Tourism, has come up with astro-tourism policy to regulate astro-tourism activities within the islands. And it is one of the first policy aspect that, or the regulatory aspect from a state government, to policy-wise and regulatory-wise approach astro-tourism opportunities. So basically what happened is community came in between, or became the center of the opportunities. And so the strategy choice was to build capacity over time, over a long-term engagement, rather than one or two workshops. And that's where the CSTEC and Open Space Foundation, which the organization I am part of, comes in as knowledge partners. And the first phase of the, you can read about the astro-tourism policy. It is available in the website of the Andaman Tourism website, official website. So the first phase of the training, or the first phase of the policy, was instrumentalized through an astro guide training program, where we had a 30-hour modular training, and we had around 20 days of initial training aspects which we did, and 18 participants were there, and most of them were already tour guides, but they wanted to engage with more with the dark sky astro-tourism possibilities. So this was locally tour operators and eco guides. There are already eco guides who do bird watching and other activities also. So these were the major demography of the participants. And the training curriculum was majorly about the, as you can see, the astronomy fundamentals, site management, visitor interpretation, how to use artistic tools to engage the aspect. We have also included storytelling
within the island called as Kachri Valley. So they do the waste management thing and waste management training and do other outreach activities. We understand that as astrotourism, within the astrotourism, how much waste management comes in because there is a lot of sensitive ecotourism, ecological areas within the sites. So yeah, certification legitimacy. All the participants who are participated in the training and have gone through an assessment and they are certified. The major aspect of it is now there is a standard recognition that given to the participants, which make it more livelihood aspects has more improvised for them, and there is a credibility that associated coming from the government. And these are the early outcomes. We have only started, the policy was released in the September last time, and the first phase of the training started in October. The next phase is starting from March onwards for another 3 months. And the direct economic benefits, we already have around 20 telescopes that are established in multiple beaches and other eco-sensitive areas within the island, and there are already small income generations that is happening within the island. And local awareness, we have connected with Panchayat Sarpanch and also included them as part of the training to make them understand about the opportunities that they can avail within the astrotourism aspect. This is the Andaman outreach education program that we have done because we are trying to cross-department dialogue is initiated tourism, environment and education. Specifically, what I have to note is that we are trying to bring in astronomy education in the technical education of the Andaman within the Andaman Education Department. So the TVET, the technical and vocational education within the vocational college, they are trying to bring in astrotourism, astronomy as a subject. So that policy and perspectives are also going on. And yeah, so the major shift is happening here, from just episodic activities to designation thinking aspects. Majorly, there is a current momentum that to have Andaman as to have a next dark sky reserve of India, and there are site identification and mapping that is happening across the islands as of now, which is taken up by the volunteers who are the participants of the AstroGuide training program, the community members itself, and there are a lot of policy dialogues that is ongoing for the lighting norms also within the tourism region. And integrating dark sky preservation within the island's broader conservation goals also is going on as a dialogue, policy dialogues. So right now I think this model actually create as a blueprint, a replicable model in multiple other contexts. We are visiting other places including Kaziranga, Sundarbans, a few other reserve forest areas where dark skies are available, and some in Kerala, Tamil Nadu borders also. So the department and the people who are involved in are having constant conversation. I welcome all of you who are interested to be part of the conversation and see if there is an opportunity to collaborate. Policy anchored, locally delivered when there is a community ownership that is coming within within the community when the people are leading, that makes a huge difference for the aspect. And there is a huge replicability potential for the model. And this is the vision that we are trying to see, of course only with the people support, as a proposed national astrotourism and dark sky network, maybe in a few years that we can build it together. So these are the key elements, standardized training frameworks for the AstroGuide people. Many of you are doing it, but how we can standardize such trainings. Certification pathways which will give more credibility for the AstroGuides, and fostering collaboration and knowledge exchange between regions. So yes, so astrotourism succeeds when dark skies are treated not as a scenery. Our tourism and civic sense, how it is not going so parallel, I guess. So how we can collaborate it, how we can be a responsible astrotourist also. That aspect also we have to consider, being the provider or being the beneficiaries also of dark skies. The two sides of the coin we have to discuss or have more conversations on. So that's about the policy aspect. I'll take 1 minute to introduce about the organization. So I'm from an organization called as Open Space Foundation. We are a registered NGO. We have we are trying to build a social enterprise out of astronomy. The CSTERG aspect that you are seeing is a manufacturing unit that we have built for producing and manufacturing affordable scientific equipments. So currently we are focusing on telescopes and I'll show you the telescope. We are doing telescope upgradation also, restoration also, as you can see on the photos. There are a lot of schools which have high-end telescopes which are in the corners. You can see the previous and now pictures. So there are a lot of restoration works of telescopes also ongoing. Balloon satellite launches, we connect with colleges and schools, do short-term research works to install like research capacity building from schools within school students and college students. Telescope workshop. We also have a STEM teachers network where around 80 plus teachers are there. And these are few of the other activities that we do, including the astro research campaigns. We have around 300 plus preliminary detentions as of now. And this is just from the 2024-25 academic year. Through multiple outreach, we have a lot of flagships programs. One of such is the NAMA telescope program that we do, which we directly collaborate with the district education department, where we connect with the taluk-wise college schools one at a time, and we have a year-long run curriculum. We start with astronomy, basic astronomy, telescope construction, where they build their own telescope. We have teacher capacity training that is going on, and other associated activities throughout an year. And also, these are some of the other activities. This is our telescope. As you can see, it's in the hexagonal shape. There are other objects, an IAU IID funded project that we are taking care of, that we are leading, called as Women Astropreneurs Collective. I just gave a talk about it, so if you are interested in women aspects within the astronomy, please do connect with. And yeah, these are the further aspects, like all the outreach programs. That's from the IAU OA telescope, the one which we got for telescope for all, initiative by academy. And this is our telescope model. As you can see, it's in a hexagon. This is fully on community side, and it's a free and open source, so you can take it. But our understanding or our thought is to make the telescope affordable as much as, and so that the people are not hesitating to buy it or to understand about the telescope, or not finding telescope as some elite equipment that we can't touch. So that's the whole idea behind the social enterprise aspects. As you can see, the one major idea behind the telescope design was the hexagonal tube that you can see. To roll the sheet, it takes a lot of precision making. Precision will be a little bit of complicated process. So when it's in a hexagonal shape, it's easy to maintain also, and do any maintenance work also. So you can directly go to the nearby workshop and get it done, get it worked out. Not to be dependent upon any big companies or any anyone else. You can also modify your own shape or style however you want. So that was the intent behind creating such a. Please do connect, and yeah, questions are welcome. Thank you.
Thank you, Anupama. Thank you very much. We have a question. Neeraj. Okay.
Hey, hi.
I'll just show you once I finish it. Yeah.
I just wanted to understand with the great Nicobar project coming in, how is that your astrotourism will cope up with the kind of port, the Nicobar project, the Great Nicobar project. Have you heard of it? There's a new port that is going to come up in.
Oh yeah. Okay.
So with that coming up, the light pollution will bloom like anything, right? So how is this astrotourism will sustain in Andaman and Nicobar?
I'm not so sure if I can tell this now, putting the mic. So local people are aware about it and they are concerned about it. And there are a lot of consultation activities that is going on for the project itself from the government side. I am not in a position to comment on it as of now. But what we can do is to read more about it and understand more about it. I am also in contact with a lot of now tell within my capacity. I hope you understand. If you're interested, we can talk more about it. Yeah.
Thanks for the lovely talk. I just had a comment to make about the way you mentioned the certification course. So maybe it's a good opportunity for me to announce that just a few weeks ago we got approval, so I can announce it. So for the last 1.5 years from the 100 Asking Reserve, we've been working with the National Skill Development Council of the Government of India to design a proper skill development course on astrodtourism. So it's very, very detailed syllabus with theory and practicals, and we spent like months on it. And it took a year for the approvals to come. They had to go through their own system of evaluation, assessment, and feedback, and so on. And as of a couple of weeks ago, it's been approved, and which means that so the course is certified by the National Skill Development Foundation. There are guidelines so it can be offered by anybody in India locally, but you have to follow certain guidelines which are given. Minimum requirements in terms of equipment, number of hours of theory, practical, etc. are all specified by the National Skill Development Foundation. So, for example, if you want to offer the course in Andaman, you could then register as the person, people doing the course, as long as they satisfy the basic requirements which are already there. And then the certificate will be then given by the Government of India National Skill Development Foundation. And this is aimed for astro-tourism guides basically, and this is applicable all over India.
Thank you. Any other questions? Okay, I'll just,
two more slides.
it's a just finish. I thought I am the last one to present, so I just want to end it on a positive note. Just if students are here, I'm also part of UNESCO SDG for Student and Youth Network. We directly connect with multiple international educational organizations under IAS, the Administrative Secretariat of the UNESCO Education aspect. So in case anyone is interested, please do connect. And I forgot the other one what I wrote, but yeah, later. Yeah, I just want to present this. This was from our last junior astronomer course, the Navaras of Astronomy Outreach. I know that all of you go through multiple emotions. Like I have been seeing, all of you have going through remote places, even urban places, making most of you taking in your own effort and time to do all the astronomy outreach activities. So I just want to thank all of you and make sure that you are taking care of yourself, going through all the Navrasas when you are doing the outreach, and end up with the always to continue the activities that you are doing. So yeah, thank you. And